Then allow me to continue. I believe we don't have a break according to the agenda, and we'll move into practice. Hydrogen in practice, ports, visions, and realizations. We'll hear from the port of Hirtshals in Denmark. We'll hear from the port of Antwerp, Bruges in Belgium, Baltic ports, Estonia, Finland, and of course the port of Venice. So I would like to call on stage Heidi Tuiskula. Apologies for my pronunciation. So funding manager, Norwegian Hydrogen. Heidi, please. Berde Kolvener, CEO, Waterstofnet in Belgium. Jata Jusila, CEO, Click Innovation Oy. And Ports of Venice, Paolo Menegazzo, right? Yeah, Head of Transport and Strategic Planning Unit in Venice. Thank you. Good. So, you heard from the beginning, from the previous session, how important it is to look at the plans of the ports and to understand the challenges, the barriers, and eventually to try to help. So let's see, because I think here we will hear 4 plans, 4 projects. What is going well, what are the barriers or what is not going well. And let's also try to have a bit of a discussion at the end to see what we can do further. So first, Heidi, let's hear from the ports of Hirtshals. And I believe you will mention also our valley, the Conway one, right?
Absolutely.
Yes. Heidi, thank you.
Angel. Exactly. The computer tried to say snow already, but we still need to sit a bit. So I congratulate everyone who is still here. You've been brave individuals throughout the day. I think I have too many slides, so I'll try to get through of them quite quickly. But my topic is basically how we at Norwegian Hydrogen have ended up in Port of Hirtshals to try to make green hydrogen happen there. So first I would like to introduce quickly I would say the key actors in the project. Obviously the port we are located in and us as the green hydrogen producer. And then we'll dive into Conway because that's sort of some would say co-funding mechanism, but I would say collaboration mechanism that we use there to get things done. So maybe in this slide, no need to go to the details, but obviously Port of Hirtshals, now when I compare to Port of Valencia, we are a bit of a smaller actor, but it is an important port, which basically acts as a corridor to all transport, all logistics from Norway to Central Europe and onwards. So it is important for us coming from Norway, for example. And maybe something which is, I think, important as a port, that they actually have this kind of a circular development as one of their key business areas. So they are not just focusing on the normal port activities, but they actually have identified it as an important part of their business. To do it practically, I think the structure is quite similar as here in Valencia, is that they have Port of Hirtshals, which is the port operator, the official doing the port activities, and then they have entity called Greenport Nord, which is sort of helping them in all this circularity and renewables aspects. And this is their vision of their circular port, and I just wanted to bring this, and maybe you'll see it later when we talk about what Conway is doing, because Conway is covering a part of this. We're not the whole thing, so port has much more ambitions than what we actually are doing in the Conway project, but it is part and it is very strategic for them to do the activities we have there. I'll then go quickly to Norwegian Hydrogen, which is the entity that pays my salary. We are a green hydrogen producer. As said, We use renewable energy to produce green hydrogen. That is as simple as it is. We don't develop any technology. We buy the best we can find, and then we implement it, and we find customers. We hopefully find the customers to buy it. We've successfully found some, but we are always looking for more. Just to say that even if we have a Nordic presence, I'm always joking when people ask, where are you from? Because I don't know what should I say, because I'm Finnish. I work for the Norwegian company, and then I have a valley in Denmark. So maybe I'm a Nordic or something, or just European. I think that's enough. But also to say that we have owners like Mitsui from Japan and Fortescue, which are like global actors. So we also have the global network from there, which we've seen very important because we are a small company still. This is just a snapshot of a few of our key projects. You can see the one there called Hellesylt. That's an operational plant in Norway that we have. We've so far sold green hydrogen from there up to eastern Finland. So some people are willing to pay even for the ridiculous transport that it is from west coast of Norway to east coast of Finland. We have one project in Denmark called Grøn Brint. This is a project where we collaborate with biofuel developer. We produce green hydrogen to be their feedstock. Rjukan project was already briefly shown in Lionel's slide. That's our newest, probably one of the projects that we are most proud recently. So this is a project towards the maritime customers where we are producing hydrogen and liquefying it to be used in maritime vessels. Then there's the Hirtshals project, which I will talk about today. And then we have in the pipeline also project in Stavanger in Norway, which is pretty much similar what we are doing in Rjukan. So if we can make things work at Rjukan, it will be more or less the same that we can do in Stavanger. If we go to the Conway project, I just have a few slides on the concept. So as said, Norwegian Hydrogen, we produce the hydrogen in the port. So we're actually located in the port because we were invited into the port. The port of Hirtshals wanted us to be centered there. Please come here, build your green hydrogen production, because then we can say to our customers that you have green hydrogen here. You can buy green hydrogen from your neighbor. So I think that's one of the importance, that even if you do small scale, like I would say Conway is still a small scale project with a 5 megawatt electrolyzer, it is feasible when your customers are your neighbors. It's not that much feasible if you need to transfer it for long distances. Some of the other actors in this slide is obviously next to us is Biomeka, which is they developed food supplements. And at the moment, they are using natural gas in their burners, and they're willing to shift to using green hydrogen in there. So they will be sort of, if you say, industrial off-taker for our hydrogen. Then the other cluster of companies on the slide, it's Hirtshals Transport Center and Vendebu Spedition. So Transport Center will be the location of the refueling station for heavy-duty vehicles. And Vendebu Spedition is a logistics company who is willing to test hydrogen-driven trucks. The last company on this slide is Honest, and that's maybe the wild card in our project. So we're not only talking about green hydrogen and how you can make business out of that, but we also acknowledge that in the process of producing green hydrogen, you also produce significant amount of heat and oxygen. Thus, it makes sense to find some use for that. And Honest is a very innovative company who is developing land-based fish farming. Some of you might know that if you do land-based fish farming, you can produce better quality fish because you avoid a lot of diseases that you could get in the more traditional ways. And for them, the business case is different and interesting because they don't really care that much how much does it cost, because their customer is willing to pay for the added value that it is produced in a circular manners. It is added value for that produce, even if it's more costly. So that's a dream business case that I'm trying to also find in the hydrogen segment, how we can find the niche markets where we can actually say that, okay, it's fine that it's cost a bit more because our customer who is using this product is willing to pay a bit more. I think we all should be willing to pay a bit more to save this planet. We can't all buy cheap trash from Temu and keep our lives like that. We all need to adjust a bit. And I think Honest is a great example of that, and I'm quite excited how it's going to develop. Maybe if we then look at the more on the broader side, we also have partners like VTT and Opura. VTT is developing, they are the academic partners, so they're developing models and helping us understand how things could look. Opura is then the industrial IT partner who is going to make some algorithms to actually manage the whole energy system there. In addition, we collaborate with Hydrogen Valley, who is doing all the communication, replication work for us. We have Board of Hirtshals, Greenport North, a lot of actors around to make it happen. If we then look what we've managed, we are now on our second year of the project. We were also happy to see that even if things get delayed, they somehow get to the end, like here you've managed successfully do, which is obviously for us goal too. So far, we've been focusing on the energy system design. Our partner VTT has developed this kind of energy system model, and we've used it, especially it's been helpful for let's say the end user segment in the project who really don't yet maybe understand what hydrogen is or what green hydrogen is and how it affects. It's been quite a good tool to actually visualize them how it could look. And actually the simulations have shown that it is economically viable and there is potential for emission reduction, which obviously makes it a bit easier when we discuss of the offtake. When we look at the infrastructure development stages, we've basically designed the concepts for hydrogen, oxygen, and heat delivery. We have the plant layout, we have a grid connection concept, we have all the distribution interfaces ready. We've done all the preparations we can for the permitting and construction. The only thing is pending is the final investment decision, and obviously that is pending the firm offtake agreements that we need. And in our case, it's not necessarily a case of our customer is not interested in hydrogen. The problem is that this world is not perfect, so you get additional challenges which are not hydrogen related in different stakeholders that you have, and we're mitigating that. But we have good leads. We've expanded a bit on the off-taker group, maybe a bit further from the port also to see how to solve it. But sort of technically we are ready to go as soon as we fix the final part of it. We haven't really been just sitting on the ready-made design, but we've been also working on the business model and exploitation part, and that's been really fruitful. I think that's where this kind of valley structure comes as a value, because you can really build this kind of a trusted environment between the off-takers, between the port, between us as the developers, and you can together discuss and sort of. What I picked up today was sort of that you have to have this kind of a win-win business model, and I truly believe in it. I've done previous work in building community business models and sort of trying to find the common value in doing, and that's what we're trying to do here also, to make sure that everyone gets something out of it. Obviously, we all need to adjust a bit, but also that everyone could make something out of it. And we've also started the replication. I think you can start replication, preparing for replication on day one, because then you'll collect all the learnings that you've had. And we've started it obviously by visiting other ports, seeing what others are doing, how we can learn from them, and that work is continuing. As a final conclusion, I've had this similar slide before, and I think it sort of summarizes what I want to bring and leave you with, is that it needs strong collaboration among stakeholders, not only the project partners, but everyone around, your whole community in there, including the municipality, including the regulators. But it also takes time and resources, and the hardship lies in walking the talk. So in a lot of time, everyone is very happy sitting together, thinking, designing things. But then when you actually need to commit, commercially commit to something, that is difficult. That is something that is not walk in the park yet. But there is, I think, positive developments in that. Obviously, continuous funding and investments are critical for project sustainability. So it's we all know that even if there are grants like Hydrogen Valley grants, which are precious, but they don't really. It's not really a funding that can maybe provide the full funding that you need for your ambitions. So then it's sort of navigating the sometimes a bit difficult landscape of different grants, national, European, all these, to find out. And private investments are one piece of the puzzle. At the current economic state in Europe, it is not easy to attract private investments. It is, if someone could magically make all the wars go away, things would be much easier for everyone, I think. Then my third point is the balance between innovative solutions and then realistic solutions, because we want actually make a reality out of it. So even if we sort of sit in our brainstorming sessions and we come up with something really high level, and we start to have planes flying to Hirtshals running with hydrogen, we need to sort of also always remember that, okay, in the short term we're going to do this realistic part, and then we leave maybe the innovation into the future business models or something like that. Yeah, final point, to focus on replication and scale up from the beginning. I think that's a key, because you need to think these projects should be, I don't know, a continuation of each other. We should think these as sort of small steps that we take towards more sustainable future. And if you start thinking what you're going to do next already on your first day of your existing project, I think then you can really succeed in both completing that and having a plan for the future. That's all for me. Thank you very much.
Thank you very much, Heidi. And I took note of your, let's say, recommendations for the future, and I'm gonna check with the next speakers one to see if we can converge. So that gives me the reason to invite the second speaker, Bert de Kolvener, CEO, Waterstofnet in Belgium, to present to us the plans for the ports of Antwerp-Bruges. Bert.
Thank you, Mirella. Just to qualify, I'm not employed by the Port of Antwerp-Bruges. I'm the CEO of Waterstofnet, but I will tackle this from an angle which is a little wider, and of course, the Port of Antwerp will come on the presentation. I would like to start from this slide, and then basically from the right-hand side. This is a study made by the Wuppertal Institute of Energy a couple of years ago, but it's over the long term, so it's still very valid. This graph shows Europe, and the color is indicating the energy deficit. Red means that there is a renewable energy deficit compared to what is actually being produced. So in that area, there is less energy produced, green energy produced as needed. In the green areas, there is sufficient or more energy produced. What it means that in the area of the Benelux, Germany, and a little the north of France, there is a systematic deficit of renewable energies. And obviously, if the ambition of decarbonization still stands, then if you can't make it yourself, you need to import. And I would like to use that specific argument to go to the left-hand side of the slide, where is the pillar number 1 of the Belgian Hydrogen Council hydrogen strategy. And we feature ourselves as an import hub. And an import hub of bringing green energy in the form of hydrogen in its pure or any derivative form from wherever the sun or the wind around the world is very cheap or efficient. And we would like to bring it into our country, and we are very happy to have the port of Antwerp-Bruges, 2 brother-sister ports. We have the North Sea ports, which is Ghent and Vlissingen, and we have Ostend. So we are rather spoiled with having so many ports in a very close and dense area. So the ambition is, pillar number 1 of the Belgian Hydrogen Council, to import that hydrogen. And I believe the ports have a very important role there to play, because they need to prepare themselves to be able to capture that new commodity, let's say, compared to what it was in the past, petroleum. Now, for as much as our ports here are importers, we also need to make sure that on the other side of the world, where the sun and the wind is cheap, you need to have ports who can actually ship that one. And very few ports are equipped to load ammonia or any other facility into big ships in order to carry them to this. So the ports, and we had that point in the previous session, what is the role of the ports? Well, they should be able to facilitate the transport of hydrogen or the derivatives from one side of the world to the local ports in here. So that's number 1 pillar of the strategy. But also pillar number 2 is important, and there the role of the ports are important, and that is the left-hand side of this slide. It's the utilization of the hydrogen in all the different forms. The port on itself brings in the hydrogen, and of course it should stimulate the hydrogen usage around the area. And Antwerp is the 2nd largest chemical cluster in the world. Houston is number 1, Antwerp is number 2. And obviously the chemical industry is an energy intensive or a hard to abate sector, so any hydrogen, directly or indirectly, can be used or should be used, and that's what we have depicted there as pillar number 1 of the Belgian Hydrogen Council hydrogen strategy, to use it in the chemical sector or to use it for steel factory, and that's also what we have, to use it in heavy duty transport. Yeah, so that's what we can use, and I think the usage of hydrogen in the port itself, as we have seen today in the tour we have made, is very good, but is probably just a fraction of what the role of the ports could be. Yeah, they have to be able to spread it around and make sure all the others could be using. And then maybe the 3rd factor of Belgian Hydrogen Council, just to be complete, is that the technology suppliers we have in our area are very much focused, and to name a few, we have electrolyzer makers, we have membrane makers, we have diffusion layer makers, we make all the projects and the technology for the off-takers. So I think the reason why the port is important is that in the overall Belgium strategy, the import and the consumption is featured around what ports could bring and give. And I'll just give you a couple of examples. It's already addressed by Stijn, but these are the activities hydrogen is currently today happening in Flanders in Belgium. Yeah? On the left-hand side, this is the current being built electrolyzer, green hydrogen production facility called the High of Wind project by Viria Energy in the port of Zeebrugge. It's a 25 megawatt scale electrolyzer, and it's going to use the green energy from the sea, from the offshore, and they're going to produce the hydrogen to be used for mobility or partially also into the natural gas grids and applications in various applications throughout the port. So that's one. It's actually being built. In the middle below, you have the refinery of Total Energy, again already mentioned before. Total Energy had a tender, and they actually called for green hydrogen to use that in their own refinery process for desulfurization. Yeah? So this allows, and this is the so-called refinery route, to make fossil fuels, for as much as these are green, a little greener, because you use, instead of natural gas hydrogen, you use green hydrogen. And so it helps, and it helps to contribute the start of the full ecosystem on hydrogen. On the top right-hand side, we have the ammonia cracker from Air Liquide. Also, Stijn referred to this one. This is a demo site, so rather small, because ammonia cracking, we still need to learn quite a lot of it. But already they have made the announced project application, meaning that from the demo, they want to go one level higher and they want to go into the more industrial type of ammonia cracking. So, and these are all projects which are happening or realized or operational today. On the bottom right-hand side, this is the Fluxys hydrogen distribution pipeline. So Fluxys, which is the Belgian hydrogen network operator, is currently building this hydrogen pipeline, which are pipes about a little more than 1 meter diameter, being built between the harbor of the port of Ghent and the port of Antwerp-Bruges. And if you take the motorway E33, going from Antwerp to Seaside, you actually see the pipes being built and put into the ground. So it's actually being done, it's actually being built. So you see that the first slide, when I showed the distribution network in Belgium, it's currently being built. Yeah. Now, what is important is that the big dots I just explained, and these are, how to say, the smaller dots of all the different kind of activities and projects which are actually currently happening in Belgium. The green dots are the one or the projects which are realized, quickly going. We have a whole palette of refueling stations, mobile applications by buses, by garbage trucks, by tugboats. The picture are illustrating that. The ammonia cracker I referred to, these are all the projects which are currently already operational. Yeah. We have the yellow dots, these are projects in the pipeline. Now, the pipeline can be short or can be long, and you know that many of you are involved in certain projects. So they are ongoing, they have been announced, and obviously, depending on the stage, the financing, the decision-making, FIDs, they are in further or closer realization. Electrolyzers, refilling stations, ammonia terminals, and so on. And the last one are the dots or the applications which we have put into a European-funded project by the Clean Hydrogen Partnership, and thank you Valerie and thank you Mirella for pushing or pulling it through. It's basically all about connecting the dots. Yeah? What we have and what I've said is that all of these dots are now systematically going to be connected to create a hydrogen valley in our region. Because in the past, what you see, these are all individual projects. And the synergy between all of them is sometimes very hard to find. And you can only prove that an ecosystem is working when you connect the dots and tell them, now you swim or now you fly on your own wings, and the business case becomes reality. Yeah? As long as the money is there from the project, it's okay, but it's after when we need to realize this. So this is what we are going to do in the project Flyports, and simply said, this will be the green electrolyzer, 25 megawatt electrolyzers, who's going to make the green hydrogen, and then one of the companies, gas suppliers, Messer, is going to distribute them to the different applications, to the refilling stations from Vidia. We have at the moment 9 in Belgium. They all get the green produced hydrogen. We will have the genset, the onshore power generation and port applications in the different ports in Zeebrugge and in Antwerp. We will have the Hister, the one we saw today in the port of Valenciennes. We will get a very similar one in Antwerp. And we have also the straddle carriers. We will have 2 additional straddle carriers. So we will have, complementary to what is already existing, port equipment starting to run. Messer will, of course, keep on serving his normal customers. And we also will apply for inland shipping. I'll come to that in a minute. Now, for as much as the green hydrogen can be used in each of these applications, it's all nice. But what do you do with a certain surplus? And the location of the electrolyzer is just next to the Fluxys natural gas grid. So whatever cannot be used as hydrogen green application, we would like to put it into the natural gas grid. And you can do this up to 2% without any concern, making the gray natural gas a little greener. Now, and for that, we have different kind of objectives. I'm not going through all of them. But for instance, the certification of the RFNBO system is going to be part of the whole exercise we are going to do. We're going to make sure that everything is going to run for 2 years. And we will make sure that the results and the ports are indicated down there are going to be replicated. Connecting the dots is important. Connecting the valleys is important. But connecting the ports is equally important. Yeah? Because all the experience we're building up on one side, you don't have to learn, you don't have to reinvent the wheel again, we can easily share. And that's also part of this project. What would we have found, we will make sure we can disseminate this in an open and fair way, just to make sure that we connect them. In the beginning I said ports will transport hydrogen from one side to another. We need to make sure that all these learnings get shared very simple and very systematically. In the meantime, on the Rhine River, now it's maybe not a seashore application, but this is the Rhine River. Everybody knows, 1,200 kilometers long, and you have seen past that a lot of small barges. The ambition of the Rhine project is to have not all, the barges, some of the barges who are currently running on polluting diesel, to have them converted into hydrogen-operated propulsion, either by combustion or by fuel cells. How are we going to do that? Of course, you need to rebuild the ship itself, and then you need to make sure the ship gets provided of hydrogen. We're going to have the ships docking. We are going to take off the hydrogen, which are stored into container-sized storage tank. So a big container full of storage tanks, 40 foot or 20 foot. We're taking the empty one off. We're putting a full one back on. Yeah, we do that usually too, so you have some redundancy, and off the ship goes. And what you can see here, this is a collaboration between the different areas indicated in kind of yellow. We have Flanders working with the provinces of North Rhine-Westphalen, Pfalzland and Baden-Württemberg in Germany. And we have the province of North and South Holland, Utrecht, Gelderland and Lelystad. So all these provinces are paying to us, because we are the program officer, to implement this project. What we are doing is, for instance, we may have to make sure that all these containers are standardized. It doesn't make any sense that one boat has its own container. No, you have to make sure that the containers can fit on all these boats. Yeah, we need to make sure customers are there, market development. We need to have sure that the ports know how to transport. We need to have a tank-tainer pool. So these containers are called tank-tainers. It's a container with a storage tank inside, and we need to make sure there is kind of a pool, like you have with the gas bottles, camping gas bottles. This is also a pool which is being shared. We want to set up specifically a company for that. We have to make sure that we get everything financed, and we have to make sure the policy is in line. So this is the ambition, this is the project, this is inland shipping, but I think it also connects, sorry I forgot to tell this, the different ports, because as part of that consortium, we have Port of Rotterdam, Port of Antwerp, Port of Duisburg and the Port of Basel. And all these ports are obviously as interested to decarbonize as part of their application. Now there are already a couple of ships, a couple of barges who have this one. We have on the left-hand side, we have a future-proof shipping with very creative names, barge number 1 and barge number 2. We have HTS Group who has the Letizia, which is a ship, a barge. And then we have the Mannheim from Contargo. So these are 4 ships, of which actually only one is running on hydrogen. This is barge number 1 from Future-Proof Shipping. The 3 others are hydrogen ready, but do not yet sail because there is no hydrogen, there is no customer, the business case is a little difficult. What we are going to do in this Rhine project is to set up a living lab. This is basically an activity where we're going to make sure that within the next 3 years, we will have these ships sailing on hydrogen. And this would need to have this tank-tainer pool, we need to have the customer, we need to fulfill the whole full business case. And all these provinces and harbors are committed to start to realize this, yeah. Which is an exercise on itself. It doesn't make any sense to promise customers we can sail on hydrogen if you can't prove it. Yeah? You really need to make sure that everything like this is going to work. Now allow me to present myself at the end of the presentation, just the 2 minutes I have still left. Waterstofnet is a small company with 2 offices, one in Belgium, one in the Netherlands. And we have 16 years of hydrogen experience. We are a knowledge and network platform, and you see all the companies. The logos are too small, but on the website you can see. We're covering the full value chain, from the production of hydrogen up to the technology providers, the implementing and the off-takers, with all the necessary support on research and on financing. And as said, and you see a couple of these pictures coming back, we do this based on implementing different projects. Yeah? The trucks, the hydrogen refilling stations, the the fuel cell generator at the time at Solvay still, the first one, was also built by us. And we also have this Hyophyn project where we're actually going to do the 25 megawatt. So this is what I would like to say. Allow me to summarize in 3 points. Hydrogen is happening in Flanders, in Belgium. You have seen that, everything. I think the role of the ports is very important. They have the role of facilitating, making sure the hydrogen gets there. They have to promote into their region, and they have to make sure the business case can be developed. The ports have very well understood that this is a new business opportunity for them, as they do for natural gas. Hydrogen is the next one. And the third one is that we have to make sure that the projects we are going to implement are sizable. And I have shown that what we are trying to do are sizable projects. 25 megawatt is big, but not so big. But we can keep it in our hands. If you go too quick, too big, people get cold water fear. They just don't dare to jump. They see the project as too big. So that, I think, are the 3 learnings or the 3 things I would like to share on what we are doing in our region. Thank you.
Thank you very much, Bert. It's clearly we will go beyond 5:30, and I hope you will stay with us because there is no way we can speed up and allow time for everybody to speak. I'm happy to see the 150 kilowatt there, the electrolyzer that we started with in 2011. That was the smallest project we start with, and look where we are today. Eh? So really happy to see you are continuing on that. I know, Jorge, you will kill me. I hope you will not kick us out after 5:30. And normally I'm a better moderator than this. But I also enjoy listening to our speakers, so apologize for that. Good. Let me move into the Baltic ports, and we will hear from a very ambitious project, which got the Valley of the Year award from us this year. And it's a valley connecting Baltic ports from between Finland and Estonia, with an especially very ambitious plan, which we like also to refer to. And I would like to invite Jata Jusila, CEO Click Innovation Oy, I hope I pronounce well, because I'm playing with all the languages, and I'm not the best one to do that. And gave time to Jorge to help us. Thanks a lot. And
yes,
floor is yours. Thank you.
Yes, thank you so much. And thank you for having me here, and thank you for the prize also. Unfortunately, I was not able to be in Brussels myself last week, but thank you so much. Today, I will, first of all, of course, I will briefly present the project as a whole, but then I will focus on our maritime cases. And as said, my name is Jata Jusila, very well pronounced, and I come from a company called Click Innovation, and the OY in the end means a limited company. It's just Finnish, sorry. Difficult language. And Click Innovation is an open innovation cluster or ecosystem that drives the sustainability transition. So we are active in the fields of the clean energy transition, circular economy, and bioeconomy. But today we will talk about hydrogen, and I'm also the project coordinator of this project, so I know the project very, very well. Yes? Sorry. Yes. I try to do that, yes. So this is the picture of our entire consortium and the region that we cover with our valley. So it's a really big one, I think by far the largest in the geographic sort of perspective, maybe also in terms of hydrogen, I'm not sure. But we basically cover with our valley the entire Baltic Sea region. We have 9 countries involved, 2 countries, you see the light green sphere, it's connecting the southern part of Finland with Estonia. So that is our main valley where most of our investment cases are located. But we have 6 more connected valleys inside our valley project, and we have some cases also in the other valleys, in the connected valleys. And our joint goal with this valley is to really develop an international hydrogen economy in this region. And as we are all exporting countries, we understand that with this work, we are really developing global hydrogen economy, actually, and of course, European one at first. It's a 5-year project. We are halfway now. We have 40 partners, 33 million is the total budget of this budget, but you will soon understand why this is, of course, not the entire funding that comes to our project or these cases that we are working with. We have several end-use industries involved, chemical, refining, petrochemical industries, the fertilizer industries, even food industries involved, of course, then the energy and the transport, including both the maritime and aviation sectors. Here you can see our implementation plan for the hydrogen production. So we have our first production plant already in operation. It's located in a place called Harjavalta, a small town inland in Finland. This case is by a company called P2X Solutions. It's a 20 megawatt electrolyzer, and they are producing clean hydrogen, of course, and part of that is converted to e-methane through a biocatalytic methanation process. So this plant has now been running for a year about. It has a capacity of 3,000 tons of renewable hydrogen per year. And our second plant is now under construction. It's by a company called Helen, which is the local energy utility company of the city of Helsinki in Finland. And Helsinki is the capital of Finland, if you have never visited, a rather large town. And this pilot plant for 500 tons of renewable hydrogen per year, it is located in the harbor of the city of Helsinki, in the main cargo port of the city. And so it's for refueling purposes, and it could, of course, then serve also the machinery of the harbor because it's located over there. It's also connected, by the way, for the excess heat with the district heating network of the city of Helsinki. So a rather nicely sector-coupled plant, and that is actually one of the main sort of features of our valley also, that we are really investing a lot of development work for the sector coupling of all our cases. Then we have a third plant underway, also again by P2X Solutions in another town in Finland called Joensuu. It's a bit bigger plant, 5,500 tons of renewable hydrogen, part of which would then be converted to e-methanol. This case, there is another investment for CCU on the site by another company that should be then connected with this plant. And they are planning to make the final investment decision next year. And then there is even one more plant, a fourth plant, a huge one, 280 megawatt electrolyzer. It's in front-end engineering phase by a company called Green North Energy in the town of Naantali on the southern coast of Finland. And their target is to produce 36,000 tons of renewable hydrogen and convert that to green ammonia. At the moment, it looks like that this ammonia would mostly go to the maritime sector, but we do hope that some of that would really go to the fertilizer industries, because unfortunately Europe is still quite dependent on Russia and the fossil ammonia for fertilizer production. So that's not a good case, and we should, when I say this, we should always remember that hydrogen is not just an energy carrier. It's a chemical component in organic compounds and can also be utilized, as said here, in ammonia to produce fertilizers in Europe instead of bringing them from maybe not so good sort of countries. I wanted to say a few things, but since I don't have now so much time, but this is not related to ports, but I just wanted to briefly mention the status of the hydrogen pool. So with our valley, we have a strong ecosystem approach, and we are doing a lot of co-creation together. This is one example of this co-creational work. So we are developing a hydrogen exchange and trading platform called Hydrogen Pool, and we will start piloting it next year. So if this is something that is of interest to you or to your investment case or valley, please send me an email. I'm just thinking that it would be a good idea to engage more players to the co-creational work so that this platform could then serve basically anybody, all cases. It's at the moment connected with the hydrogen pipeline plants, but it's designed so that it actually can be also disconnected from the pipeline transport. This is the full map of our investment cases. but today I will focus on the maritime-related ones. We have altogether 7 ports under development within our valley. In 3 cases, our partners are developing next-generation marine fuels, and then in 2 cases, the partners are rethinking the vessel engineering. Since I don't have that much time, I will focus on 4 of the ports that we are actively developing. The first one is Port of Visby, which is located on the island of Gotland in Sweden. So it's in the very middle of the Baltic Sea. And this island has the goal of developing a fully integrated energy system for the island so that the port would be basically fully integrated with the island's energy infrastructure. They have also other development projects ongoing in parallel to our valley, and for instance, they have this hydrogen-ready ferry development ongoing in these other projects, so that's not part of our valley. In our valley, our partners are studying the hydrogen supply and potential maritime applications in this port of Visby. So they're analyzing the port operations, bunkering concepts, and then integration of the port with the energy system of the island. In addition, our partners have already developed this extended reality environment that simulates the hydrogen and ammonia bunkering operations in this port, and they have been using that for training already. And for instance, this kind of safety analysis that you can see this snapshot on my slide. So work is going very well, and it's really nicely aligned with the other efforts of the island of Gotland, and they have this goal of becoming a real-world test bed for these hydrogen-based maritime and regional mobility solutions. Then to my next port called Port of Rönne, which also is located on an island in the southern part of the Baltic Sea. That island belongs to Denmark. And this island as well has a goal of becoming this kind of an energy island where they connect the offshore wind, P2X, and the port operations together through, and then smart grids, even there. And in our consortium, the partners are studying the hydrogen and or bunkering facilities to be designed for the Port of Rönne. So they are analyzing the logistics, the local demand, and how this bunkering could be integrated to the Baltic hydrogen corridor. So this work goes very well, and as my goal was to somehow explain you how this really is an ecosystem kind of effort and not everything can be done with one project. So also they have some parallel projects ongoing. They have a nice industrial consortium in place, and one of our project partners, Wärtsilä, is also in their other projects, supporting with aligned goals. So very nicely complementing the work that we do in our project. Then I will move to Latvia. We have 2 ports in Latvia. The first one is this free port of Riga, the capital of Latvia. And this place or site is a really industrial hub of Latvia. And this port has also a strategic role in the hydrogen strategy of the country of Latvia. And in our project, our partners are assessing the feasibility of converting the port's own operational vessels to hydrogen or hybrid propulsion. And they also are evaluating the portside energy and bunkering infrastructure. Again, this is going nicely, but there are no investment decisions yet by the port for the bunkering. But anyways, the feasibility work is good, progressing well. And again, I wanted to bring one more ecosystem type of complementing activity here to the table is that the port has this year announced a rather large investment decision for the infrastructure development in the port, like roads and things like that, over 7 million. So very nicely supporting, again, the activities that we do in our project. And then last but not least comes the port of Ventspils, which is also in an industrial type of hub on the west coast of Latvia. And they have a goal of developing this site to a strategic green ammonia hub and an enabler for a cross-border ammonia and chemicals and fuels exchange. And in our project, the partners are analyzing the potential transformation of the existing ammonia terminal into green ammonia production, storage, and maritime bunkering hub. And the scale is rather large, 250,000 tons of green ammonia. And again, our partners are conducting their pre-feasibility study and engaging with the Freeport Authority. And they have also a parallel activity there with an initiative called Purple Green Energy, in which they are developing a large-scale renewable ammonia export plant in this particular port. So many activities for ammonia, green ammonia, and also hydrogen bunkering in all of these ports. But has then the sailing been smooth for us for all the cases? For the ones I showed, it looks like quite promising and work is proceeding well. But we have also had some bumps, or how would you say, on the way. In the middle here, you can see with the red color I marked, there's one case that we had to cancel. It was for bunkering of hydrogen to ships. And our partners wanted to conduct a feasibility study and make an investment plan for a hydrogen marine bunker station for a ferry route between the city of Helsinki and Tallinn in the middle part of the Baltic Sea. But this we had to cancel because there were simply no ferry operators ready for this at this stage. Then the first one on the list, that's still there, but we had a case for this fuel cell case that's supposed to be first conducted on a port, actually in the Vuosaari port, as a modular solution, so that after the demonstration it could be put on a vessel. But unfortunately, we have had really big difficulties in finding a proper site, a proper port for this demonstration. And now we had to adjust the demonstration so that it will be conducted as a modular, still, but a stationary onshore demonstration. And then there are some very good news is the one case that I already mentioned that has actually tripled its size during the 2.5 years of our project running. And this is the green ammonia for maritime transport by Green North Energy, the 280 megawatt electrolyzer investment. So it really has tripled the size during these 2.5 years. And of course, it takes time because it has grown. So unfortunately, they are not able to deliver it before the end of our project. But anyways, they are doing the front-end engineering phase at the moment. And as you can see in the small map over there on the right lower corner, all these cases, Naantali is this case for Green Earth Energy, is also located in the harbor of Naantali. It's an industrial harbor. And then we have all the bunkering stations and storage stations in the southern part of the sea. So nice connections between the different cases by different players in our consortium. So this was the case that I now mentioned, and then comes my last slide, with which I wanted to simply say that we have, of course, understood that most of the ships don't simply sail around the Baltic Sea. Some do, but most don't. And as our goal with this consortium is to build an international hydrogen economy, we understand that most of the ships will exit the Baltic Sea through this Skagerrak, which is the narrow part of the sea in between Norway, Denmark, and Sweden. So we are thinking that we should probably engage now in the next phase more with the North Sea ports to make really our vision of the hydrogen economy a reality. So you can find this through these links, and thank you.
Thank you very much, Ata. Indeed, I was thinking exactly that soon we will see starting the connections. And I believe that the most obvious one is the North Sea one. Yeah. But really, really ambitious project, which when we awarded the grant, we didn't think that it's going to go so far. Now, for the last presentation from this group, and I promise to finish not far from the expected finish, is the Port of Venice. Paolo Menegazzo, Head of Transport and Strategic Planning Unit. And really looking forward to hear from you, because this one, I know the list. I recognize.
Yes. Okay. Thank you very much. I will be short, so we can survive. I'll start. Venice is a very complex port. Ports are all complex, but Venice is inside the lagoon of Venice, is very next to the old town, so every time that you do something, it's difficult. And so for this reason, we really take a lot of attention of everything that is in the direction of finding a balance between port activities that we have to improve, we want to foster, but also to respect of the delicate environment that we have all around our port. So we are working a lot on improving our nautical accessibility, but always taking care of the environment. We are working a lot for improving rail sectors, but first of all, we are working also for finding alternative fuels that are really important for the environment. Since some years ago, we started to understand what can we do with hydrogen. Is something that is fine for our port or not? Which would be the magnitude of hydrogen for our port? So we made a study with Roland Berger to find market demand for the Port of Venice. And we were really surprised because we realized that we have real big numbers for Port of Venice, because we can combine the real use for port users, for tractor in the port, trucks, and so on, ships, tugboats, but also there is a huge demand of use of hydrogen for all the factories that are all around the ports of Venice. So we start with some political agreement. We signed the memorandum of understanding with the hydrogen park that is located, of course, in our port. We are member of the European Clean Hydrogen Alliance, and so as public body, we do not do direct investment from our known as a port authority, but we foster private investor in our port, and we want to follow all the different parts and actors that we can have in our port. So user in the port, we need a fuel station, we need storage in our port, but we need also to feed all the industries that are around the port area. So I will now, very fast way, to show you three projects. Two are already in place, one is a long-term project. The first one is from Sapio. Sapio is a famous and historical producer of hydrogen and other kind of gas. At the moment, they already produce hydrogen in the Port of Venice. They have a pipeline that distribute the hydrogen in the network, but now they are building a new hydrogen production plan from renewable energies. It's a photovoltaic plant. You can see here in the pictures. Last July they started the works. Is supposed to be ready for the next summer. It's a total investment on the 24 million euro, and we estimate to have about 750 tons hydrogen for years. The second project, also this one, it's already in place in the Port of Venice, is an investment of about 50 million euros, again for building another electrolyzer of about 8 megawatt, and they are going to build also a fuel station. Why we need this station? Because municipality of Venice bought about 100 new buses, and they need a fuel station. Where to do the fuel station? In the port area, so that it's safer. Port area with all the chemical activities that we already have in place, it's able to manage such a product. So it's the natural way of when you build a new things, you go where they can use it. And then we have the third project. This is from Edison. It's a more long time scale. Is the idea of building an offshore base for import of ammonia connected to the mainland through a pipeline. At the moment we are in the feasibility study of this, but numbers says that it's something feasible, also because Edison, they have a power plant inside Port of Venice. It's a power plant already ready for starting with hydrogen, so we need to the energy to go on in this direction. Thank you very much.